Okay, so then pull up our trusty calculator. Okay, so all we got to do, and I want to sort of model how to use the calculators well too, because you can kind of learn to be more efficient on the calculators. On this one, it's definitely easier to just do the whole thing at once, right?
Yeah.
You don't need to do it in pieces. So square root of 16 squared plus
Oh, I see.
3.1 squared, right? Okay, does anybody have any questions about that?
No.
Right? Okay. So 16.2975, blah, blah, blah. But what are our sig figs going to have to be? Because these are presumed to be measurements. 2.
16.
So 16, yeah. Okay. Now, what else here? So we got to find the angle, right? The angle theta.
In degrees, mode. Degrees.
Right, you got to be in degrees mode. So we're going,
Mode.
where's mode?
Oh,
Right there, there we go. Mode, I'm in degrees.
Perfect.
So on this triangle then, how would we define those sides relative to that angle? This would be opposite and adjacent,
TOA.
right? So that's clearly, that's a TOA, right? Opposite over adjacent. So we know that tangent theta equals 3.1 degrees over 16 degrees, right? And so theta must equal inverse tangent, 3.1 over 16. Questions how we did that?
No.
That's the same, I'm just gonna, to get from here to here, I took the inverse tangent of both sides of the equation, right? So the inverse tangent of 3.1 over 16 is, well, that, we don't know yet, it's some number. The inverse tangent of tangent cancels it, right? Okay? So we put that in our calculator. Inverse tangent, and if you want to be really fancy, you can do that. You don't need to. Inverse tangent of 3.1 divided by 16. Oops. There's a reason not to do that, maybe. Equals 10.96 to 2 places. 11. And I'm just putting in the numbers, correct?
Yeah.
Correct. You got to get used to that. That's one thing that'll make it easier to make these questions. Okay. Questions?
No.
We good? Okay, that part's good. Put that away for a second.
Part 4 is 2.
Okay. So let's go, and those were all pretty much the same. Do we want to skip to part 4?
Yes.
Okay.
Now I want to spend more time doing. Yes, there is. Yeah. No.
Okay, here's a good one. Okay. Yeah, there's 2 that are similar, and then there's 1. The last one is tricky. It's pretty tricky. You got to really think about the last one. Okay. Should we look at 2 maybe?
Yeah.
That's got 3, doesn't it? Yeah. Okay. Yeah, that's a good one. Okay, so okay, so this one, let's do 2 things with this. Let's maybe draw the picture, and then we're going to take the vectors individually, independently, and we'll break them up into components. I think that's helpful to do. So here's kind of, there's our coordinate plane. Ship heads 8 meters per second at 36 degrees north of east. So that's east. and that's north. Does everybody see that means we're starting here and we're swinging up like that?
Yeah.
Okay, so let's draw that one in. 36 degrees, and it's 8.02 meters per second. Okay?
Yeah.
Next one. Due northeast at 5.01 meters per second. Well, what does due northeast mean?
45.
45. Okay, so this one's going to be kind of up like that. 45 degrees relative to the horizontal, right? Does that make sense?
Why? Because relative?
Well, no, but if it's moving due northeast, right? If the current's flowing due northeast, then we know that the current's flowing in that direction.
Okay.
Does that make sense?
Ships kinda.
Right, right. Okay. And the length of this one was 5.01.
Mm-hmm.
I'm just gonna leave the units off. We know what they are, meters per second. Then the last one, okay, you gotta be this one you gotta be really careful with. A passenger rides a scooter along the deck at 6.41 meters per second at
East of
40
north.
degrees east of north.
60 degrees.
Okay, so you could also make that if you wanted to. How many degrees? 50. You can make it 50,
Why?
or well, you could because that's 90 total.
Okay.
So James, go ahead.
Isn't that irrelevant because it's talking about the velocity of the boat?
That's what I got too.
Yeah, that's
Because the question says, what's the velocity?
Oh, it
of the
does?
boat?
Yeah, I thought it was just like a.
That's
default.
why.
Oh, it does?
Maybe that's why I couldn't get that one.
Shoot, that's the
I kept.
Oh, that's the problem. I'll change the wording.
I
So
thought,
it's,
I thought you were trying to trick us.
No,
and just
I
put it in there.
I wasn't. Kick myself. No, that's the problem. Yeah. No, so you're trying to find the velocity of the dude riding the scooter, okay,
Okay.
relative to the shore. So there's the issue.
we go.
Yeah.
keep going.
Okay. Yeah, we'll keep going. Definitely, we'll keep going. Okay, so now there's two ways we can do this. I'm gonna do it the way they have it. I'm just gonna leave it as
40.
40 degrees east of north. So this is north, right? And so it's gonna look something like, it's 45, it's gonna look something like that, where that's 40 degrees, and that's 6.41.
Well, that's
Okay,
weird.
we can do it either way. We've gotta add up all those vectors, right?
Right.
Okay, but that looks like a mess. Don't do it that way. You don't, this picture right here is actually completely irrelevant. You don't need to even think about stringing them all together like that, because, why did I just do it then? Yeah, good question. So, because we're not gonna bother trying to connect those and find the resultant. We're gonna find the resultant instead by finding the x and y components, the east and north components of each one in a table, and just adding them up.
Yes.
You see what I'm saying? It's a much easier, cleaner way to do it. So let's take the red one by itself.
One back.
So let's take this guy. This one is 8.02 at 36 degrees. The blue one is 45 degrees, and it's 5.01. And the purple one was 40 degrees on this side, and the length was 6.41. Okay. Which you could optionally make 50 degrees on this side, right? Because they have to add up to 90. What do we call that when two angles add to 90?
Supplement, complement.
Complementary. Yeah. If you said them both, you'd get it right.
Yeah. 50-50 chance.
There you
And
go.
I got it wrong.
So let's go ahead then and break this guy up. So on this one, if we want to find the x component and the y component, let's put those on our table. So our table, really, all it has to have is v for vector, or, let's do that. Just got to have a column for which vector you're talking about. We have to have a column for the x component and a column for the y
Why?
component, right? So for the red one, what are we gonna get? We'll call it vector 1.
Oh,
So what are we gonna get for, we can call it whatever you wanna call it, what are we gonna get for our horizontal component? Now, you know the pattern is, on these is always the same. You're gonna multiply the hypotenuse times either a sine or a cosine when you're taking a component, every time. So which one is it here? Now, here's the angle. How do we label these sides? If that's the angle,
Opposite is opposite.
opposite and adjacent, right? So which one then, sine or cosine, goes with the horizontal component in this case? So the sine's gonna be the opposite,
Yeah.
right? And the cosine is the adjacent, because remember what our SOHCAHTOA triangle looks like. If this is our right triangle, opposite, adjacent, hypotenuse, and we spell SOHCAHTOA like that. So this tells us that sine goes with opposite and cosine goes with adjacent, right?
Yeah.
So then we know that the x component here is gonna be 8.02, it's the magnitude of the whole thing,
Cosine.
times cosine of
36.
36 degrees.
Which is just
Some number on your calculator.
6 point.
And the y component, the y component is gonna be 5.01 times,
Wait, why? Why did you just switch triangles?
I'm sorry, what am I saying? Strike that, jeez. The y component is, sorry, is 8.02 times
Sine.
sine. Good. Okay, now we switch triangles. Okay, call this vector 2. So for vector 2, let's see, I'm gonna start picking on some people here. I'm gonna go down the list. How about, I'm gonna take roll 2, that's how I'll take roll. How's that?
Why are the two?
Okay. I'll take roll in a second. All right, so let's see. So on this one, then we want to get the x component, right? So Tanner, how are we gonna do that? That's gonna be what for the blue vector?
5.01 cosine 25.
Good. Okay.
45.
Oh, 45.
Just
See
read
if-
over it.
See if you're paying attention. Okay, Frank, how am I gonna get the y component? Yeah, sine, right? Good. Times sine 45. Very good.
Aren't those all kind of the same?
Yeah, they are.
Yeah.
They're gonna look very similar, aren't they? Okay.
Somewhat related.
Vector, oh, I gotta be purple. Vector 3. What am I gonna get here? Now, this is a little tricky. This one's a little tricky. Focus on
Oh,
this, right?
Well, can't you
Okay.
just draw the triangle and
So here's our triangle. You could, but now, as we've got it drawn right now, that's our triangle, isn't it?
yeah.
Okay? So this time, for this one, this is the opposite side, and that's the adjacent side, right?
Oh.
Make sense? Okay, so,
So you just put
anybody volunteer on this one?
So
What do you think? Go ahead, Brad.
Would you be allowed to just switch it, go 6.41 cosine 50 degrees?
Yeah, you could, that's fine, so we'll write it, that's fine. So you could say 6.41 cosine
Or you
50
could make that
degrees,
sine.
or, it doesn't matter, it would be 6.41 times
Sine 40.
sine, everybody see that?
No,
Times the
no.
sine, if this is the triangle we're using, then the
Oh, because you subtract.
the
90.
horizontal
Okay.
component gets associated with the sine, because it's the opposite side this time. Okay, make sense?
Is it because east with north, you're subtracting it?
Exactly, because we started here and went this way, yeah. So we defined the triangle a little differently. Either way is gonna work, but you have to be consistent. You just gotta figure out which angle you're gonna use. Well, actually, you don't, am I saying? You don't even really have to do that. We could mix and match. This number's the same as this one, but you're not typically gonna do that. You're just gonna pick the angle to be either 40 or 50 and stick with it.
30, 40, or 60? Oh,
40 or
sorry.
50, sorry,
Never
40 or
mind.
50. So if we said, let's just be consistent, if we took the angle to be this 50-degree angle down here, so we're using this triangle, then the y component would have been sine again, wouldn't it? 6.41 sine, oops, 50, I was right, gosh.
Oh, don't do that.
Oh. I don't know this. Or, if we chose it to be a 40-degree angle, then it's actually the vertical component, and you see these components, right? There's the vertical component, there's the horizontal component, right? The vertical component would include the adjacent side, so we need a cosine.
I can't picture in my mind why the 40 is on the other side. East of,
Yeah, I don't.
east of north, like how do you draw that
Okay, so here's how you do it.
mentally in my mind?
You go like this, so here's north, and there's east, right? So I'm gonna start up here,
Yes.
and I'm gonna swing that way, east of north.
Okay, yes.
See what I'm saying?
Yeah.
Okay. All right, so there's our stuff, and just so we don't get confused on this, I'm just gonna we'll take some of those away. So then all we have to do is come up with what the resultants are, the components of the resultant, because when I add these up now, whatever I get here is just gonna be r sub x, isn't it? Right? That's the x component of the resultant, and that's the y component. We can do this on our calculator. This is another reason that having a graphing calculator, and I really think having a graphing, like even, I would say the TI-84 is a lot more useful for stuff like this than the TI-83 even, because you can move around and manipulate the numbers so much more easily. You'll see that in a second. Oh, something wrong. Oh, jeez.
What is going on?
It's the story of my life. It's one big struggle. Oh. Really? Don't do that. Don't blow up. Just stay like that, right there. There, okay. Okay, so watch this. Watch how we can do this now. I'm gonna put in this whole list. This is pretty slick. This makes it really easy. So we're gonna find out what is 8.02 times, I sure did. Sure did.
It's getting worse.
Yeah.
Did you hear that?
Cosine 36 plus, just adding up this column, right? 5.01 times cosine 45 plus 6.41 cosine 50. Oops, I didn't put a times in.
You don't need this.
I don't need to?
Yeah.
Okay,
Yeah.
cosine 50. Okay, enter. Okay, there's an answer, right? I'm just gonna leave it in the calculator though, because it keeps it with like 20 digits of precision, so we'll just leave it there. Now I wanna do that, I gotta go through that whole thing again?
No,
Heck
just
no.
pick it up and switch.
Yeah, I just go up here like this. And it doesn't do it on here, but on a regular calculator, it's really easy to do. You just go through, if I put the cursor over the C and I type sine, it just replaces the whole function. On here, it doesn't work that well for some reason. It's really annoying. See if I do sine. Oh, I did it that time. Never mind.
What else would have happened?
Last time, I must have screwed it up. Did something wacky.
Oh,
last
wait.
time. Oh, and how do I get all the way to the left?
Second left.
What?
Isn't that cool? Kind of bells and whistles. Enter. So there's my y
X and
component.
Y.
X component, y component. So now when I want to calculate the resultant, the magnitude, all I've got to do is just go square root of that guy,
Square.
enter, squared, good, plus that guy squared. Okay? 19.329. So it's out to how many? I think this one, did it go to 3?
3.
I think those were point.
And let's do the decimal, what's it called?
If you count
Degrees.
degrees
Degrees.
Were those point zeros or not on the question? I can't remember.
Point zeros.
They are point zeros? Okay, so if those are point zeros, then we got 3s. But you can just, I mean, that's easy, you just check that.
Yeah.
So 19.329, now to get the arctangent, we just go second arctangent, and we're gonna take y over x, correct? The common mistake is to do the x over the y, but if you think about it in terms of the triangle, I can't draw right now, let me just move it away. In terms of our triangle, let's just use this one. That's opposite, that's adjacent, there's the angle, right? The opposite is gonna be the y value,
Uh-huh.
right? So we've gotta do, that's the second number, right?
14. Oh, yeah,
Yeah.
So that one
Oh,
divided by that one,
oh, yeah.
there it is.
It works.
Make sense?
Yeah.
Okay.
So it's like the other ones, but there's like 3 instead of 2.
Right, 3 instead of 2, and the table really works. The table is definitely the best way to do it. Take each vector, what I would do is take each vector, it's harder to do up here because I don't have enough real estate, but on paper, I would take each vector, draw it separately, build that table vector by vector, just the horizontal and vertical components, and then all you have to do is add them all up to calculate everything you need to know about the resultant. What that does is it trades all this mess effectively for one really simple vector that's built up of an x component and a y component, so we can find what the vector is. Okay? See how that works? Okay, now, so I need to change the text on that one to say on the scooter.
Yeah.
All right, I will do that. Just know that until I get it changed, that's what it is.
Oh, these are cool.
Go away. Oh, where did my? Oh,
Oh,
yes, you may.
oh,
I don't think this is the one I've always had. Somebody switched it on me. Okay, what about this one? This is a good problem. It's tricky.
This one was,
This is gonna make you really think.
Actually, all of them made me think. Just saying.
This one will really make you think.
What's
You gotta be, so you might even put like a washcloth on your head so you don't overheat. It's gonna
Yeah.
really. So, I do. So, an airplane flies with an airspeed of 338 kilometers per hour. A wind blows at 39 kilometers per hour at 30 degrees north of east relative to the ground. So picture that, right? So we don't know anything about the direction of the plane yet.
No.
This is the airspeed's blowing like that though at 45.
Yeah.
Okay. In order to land at the airport due north, so we want the plane to go due north. This is asking, how should it steer? In what direction should the captain point the plane in order to go due north? No,
West
if he
is
points
west.
north, the wind is gonna blow him.
west.
He's gonna have to point the plane a little bit this
So
way,
that it
isn't he?
catches it
Right.
and takes it.
Yeah. Now I'm not gonna give you too many secrets on this one.
What?
Let's at least draw a picture. So here's the wind. Right, the wind is blowing like that. I want the airplane to end up landing right up here somewhere, don't I? So we need the velocity vector to be due north. When we add the vectors tip to tail, it has to be due north, doesn't it?
No.
Yes.
So this guy right here is gonna, even though it's much faster, it's gonna be a longer vector, it is gonna have to have, so it lines up, so the resultant vector, when we add all these tip to tail, the new color, when the resultant vector is determined by adding the vectors tip to tail, it would have to go due north. So this guy right here, everybody see that this one is actually, it's at some angle, isn't it? We had to steer it west a little bit to compensate for the east component of the wind, right? So here's the hint I'll give you. What can you tell me about, if I look at the components of the wind vector and the airplane vector, what can you tell me about the horizontal component of the wind vector compared to the horizontal component
What?
of
They're the
the
same.
airplane? They have to be opposites, don't they? Right?
Yes.
Does that make sense?
Yeah.
So there's kind of the trick.
No.
The horizontal component of the airplane speed has to be exactly what the horizontal component of the wind speed is in the opposite direction.
It's like a huge.
Okay, so that's kind of tricky.
What?
Not tricky.
All is good.
All right.
I'm lost.
So how might we? Let's just kind of. Maybe we could use a little bit more of this. So how could we maybe set that up then?
Well, we gotta find that theta, right?
We got to find the theta. Let me get rid of all this stuff. So
You have to find.
And you have to find R, and those two have to equal each other, or be opposites.
You find the x of y of the wind.
now we're getting somewhere.
Choose.
So what's the wind speed?
300 and, oh no,
39.
sorry.
It's at 45 degrees.
30 degrees. 30.
What's that?
No, because that's.
Oh, you're right, it
The
is
one
30.
goes at 39 at 30 north of.
You're right. No, you're
Oh,
right.
good. You panicked me.
Oh.
Okay.
30 degrees north of east. Okay, so let's come up with the components of that then. W for wind. Okay? So how are we gonna do that?
We are gonna find it.
Find the sine, 39 sine 30
Okay.
and 39 cosine.
Which one goes with that?
X with the cosine.
Cosine, everybody agree? Because if I draw these components in here, like so, this is opposite and that's adjacent for that angle, right? Okay, so 39 cosine 30, 39
Sine.
sine 30, right?
Okay.
Okay, we got those. Now what?
So we gotta.
Find something else.
You would, so you get the numbers and like A would just like levitate up to
It'd be
like,
negative though.
the planes vector.
Oh, so
and
smart.
then you would do arc sine of theta.
Okay, so we're gonna have to do
We
something
use
like that, aren't we?
X,
Right, so
yeah.
we gotta, so let's maybe try to draw a picture that goes with that. Right, so we know, all we know is that this is gonna have to be the west component of the plane's velocity, right?
Right.
Right. So we could kind of, we already know, if we were to draw the picture for the plane, it's gotta look like this. No, I can't have blue. Yeah, I can, I'll just do blue. There. Okay, so the plane then, it's gonna be going up at some angle, right? so that the x component has to be the opposite of that, doesn't it? Right? The plane's velocity we could break up into the two components.
And that's gonna be our x right there.
Which is what we already have though.
Everybody agree?
Yeah.
So for the plane, if we call this P for plane. Oh, gee. That was kind of fun. So P for plane, then this is just P sub y, and that's P sub x. Everybody see that? The x is always gonna be the horizontal one.
But doesn't P sub x have to be the same as the x here?
It does, has to be the opposite, doesn't it?
So
Right.
it's not.
We don't know what the angle is yet though, do we? Let's just call this angle what? Theta. Usually we use theta, we use something like that for angles. So we'll call that theta, right? So can we set up an equation then? We know that if I were to do the components,
Don't we know that P, the big P is?
and we do know that, don't we?
3:30.
Yeah, we do. How, what was it again?
3.8 something.
338. Okay, right. So we do know that. We know the magnitude is 338. I can still put a P there. So it's going to be 338 times what?
Could you do it
Wait,
cosine and then compensate for the 30
We
degrees?
could. And let's be tricky about this. We don't need to use some fancy angle. We could just let the theta, I mean, technically, the angle starts there. If we're going to go north of east, it starts there and goes all the way up to there, doesn't it?
Yeah.
Right? So it's going to be a number bigger than 90, right? we can do that. That's fine. But, well, I mean, I don't care. We can do it that way. Or you can say this. You can just work with this nice little right triangle here, and when I solve for theta, what do I have to do to it? I gotta add 90 more, don't I? Because if I measure this angle, really if we're measuring the angle, how far it is north of east, then I have to start at east and see how far I swing up, right? To me, I always prefer to use the easy small angle and just add any extra there. Does that make sense?
Yes.
Okay, so let's solve for this theta, and then we'll do that.
Why is the x the same as the other x?
Well, it's going to be, right?
If we
It's gonna be,
put
now this is gonna be a sine relationship, right? Because if this is angle theta, that's opposite and that's adjacent. So isn't it gonna be 338 times the sine of theta, whatever that might be, right? And we actually know it's gonna be the opposite of that. It's gonna be negative, isn't it? Right? We should probably put a negative sign because it's going backwards.
But,
Okay. The vertical component is gonna be what? What do you think?
adjacent over
Cosine.
So it's gonna be a cosine, right? We know that this, I should maybe write a number. I bet you that's confusing to have that be a p. Let's make it a, whoops. Let's make it a number.
3.38.
All right. So this one's gonna be 338 cosine, the vertical component of theta. What do I know has to be the case with those components?
You have to compensate for it.
Yeah, these have to add to zero, don't they?
Yeah.
Right, because we know, does that make sense? We know that these two have to, when we add up the resultant of all this stuff, the plane's being blown by the wind, and it's driving in a certain direction, but we want the result to be, the resultant vector to be that it goes due north, right?
Okay.
Yes.
Why did you make it negative on the?
Because of the direction, right? Would you agree that this component is going backwards in this triangle? So we can, that's a good question. So we can see, because it's going in the negative x direction, we always say, remember our convention, we always say for directions in kinematics, that the positive x direction is positive, positive y direction is positive, and the others are gonna be negative, right? So that vector has a negative, does that make sense? Negative direction, okay? So these things have to add up, and when we add up our resultant then, we know that has to be zero, doesn't it? Right? Because we don't want there to be any x component. We want the plane to actually end up traveling due north.
Oh, so
Did you switch the cosine and sine over, right?
No, I didn't, but look at the angle we got. See, the angle's right here this time. Does that make sense? Okay, the way I drew it. Okay. So if this is the angle theta, then it's the opposite component is the one that's associated with the x component, right? Opposite side. So it's sine. Is that, give me a 1 to 5 on this. I gotta have a little, I take the pulse. 5 meaning I'm totally following you. 1 meaning I don't have a clue what you're saying. 3 meaning I'm kind of in the middle somewhere. Just covertly give me a little, just flash me a little. Okay. All right. All right. Okay. 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 That's good. That's good. I just want to get kind of an idea where we are. So then all we've got to do if we want to solve this thing is I'm just really, if I want to know the direction, it's right here. Those two things have to add to 0. This component to the east has to match that component to the west, so the plane is canceling out the effect of the wind, right? So, well, so we're gonna find out. No, not necessarily. We have an equation to solve. We've got, if negative 338 sine theta, hang on a second, I gotta write this out better, plus 39 cosine 30 equals 0, all I have to do is just push this to the other side, right? Everybody agree? So I end up with 39 cosine 30 equals 338 sine theta.
Yeah.
Okay, we'll finish this one up. No. This, now by the way, this is a really hard problem. This is a very, very hard problem. It's a tricky one. Maybe it's kind of like what I'd probably do on a test is make this one not worth very many points, so you can still get a good solid A without answering it. But if you want to get 100, you got to get this one.
Okay.
We do tests, we do someone kind of do like write out.
You know, I'm not sure. I might do a little of both in here. Yeah, we're definitely gonna do some book stuff in here too, because it's just there's gonna be some stuff that's gonna be hard to do on Moodle.
I
And
feel
it's,
like I could write that all out and then mess up something and they get the wrong answer.
yeah, yeah. No, you could. All right. Got to take roll, of course. Hey.
Go. Go.
You guys are so polite. This gentleman, you first. No, you first.